Welcome back to the session. In this video, I am going to discuss about magnetic force acting on a current carrying conductor placed in a magnetic field. Okay, so look at this circuit diagram here. This is called retard stand, and we have a horseshoe magnet. So horseshoe magnet means, already I wrote here one point, horseshoe magnet already producing a permanent magnetic field. So whenever magnetic field is present, magnetic force also will be there. Okay, so this horseshoe magnet producing a permanent magnetic force. Okay, now we have one aluminum rod. So here AB is the aluminum rod. One end of the rod is connected through a key with respect to a battery, and the other end is connected to negative terminal of the battery, right? Suppose if key is closed, then the current I starts moving through the conducting wire from positive terminal to, first it enters through the aluminum rod at point B and it reaches to point A. Again this current which is finally reaches to the negative terminal of the battery. So this is the exact direction of the current when key is closed. Okay, so according to magnetic effects of electric current, whenever a current is flowing through the conductor, it produces a magnetic field. Am I right? So whenever magnetic field is generated, magnetic force also will be developed, right? Yes. So definitely whenever a current is flowing through the aluminum rod AB, due to this flow of current, there must be one more magnetic force is developed. So look at the second point here. Due to the flow of current in the aluminum rod, the rod also creates a magnetic force. Okay, so already horseshoe magnet, this horseshoe magnet producing a magnetic force. Due to the flow of current, the aluminum rod also creates a magnetic force. So at a time we have two magnetic force. One is due to horseshoe magnet, another one is due to flow of current in the aluminum rod. So at a time we have two magnetic force, means what will happen? Either it will repel or either it will attract. Correct or not? So due to the flow of current as well as due to the two magnetic forces, this aluminum rod moves towards the south pole direction. Moves towards the south pole direction. So look at here Fleming's left hand rule. According to Fleming's left hand rule, the central finger represents the direction of current. So here I is called, green line is called current, and forefinger represents the direction of magnetic field, and thumb represents the direction of magnetic force. Okay, so already in aluminum rod we know the direction of current from where to where, from B to A, which is moving in this direction. So here central finger represents the direction of current. Okay, and forefinger is the direction of magnetic field, right? So here magnetic field is moving from north to south. So therefore according to left hand thumb rule, thumb represents the direction of magnetic force. So due to this magnetic force only, the aluminum rod moves towards the south direction. Okay, so finally we got a magnetic force, right? Just a second, I will erase these points. Yes, thank you. So finally we got some magnetic force, right? So whatever the magnetic force was generated, that magnetic force depends on three components. Okay, so magnetic force is directly proportional to B. That means when the magnetic field is maximum, therefore magnetic force also will be maximum. Okay, so whatever the magnetic force was generated or developed, this magnetic force depends on the flow of current in the circuit. That means if current flowing through the circuit is maximum, it creates more magnetic field. So if more magnetic field was present, means more magnetic force was generated, and this magnetic force is directly proportional to length of the conductor. That means if length of the conductor is maximum, which allows maximum current, when the current flowing through the conductor is maximum, it creates more magnetic field. When more magnetic field was created means more magnetic force was generated. Okay, so this magnetic force depends on three components, that is BIL into perpendicular component of theta. That's why F is equal to BIL sine theta. Okay, if theta value is equal to 90 degree, sine 90 value is 1, therefore F is equal to BIL. Okay, so from this we can calculate magnetic field also. B is equal to F by I into L. Okay, so I hope you understand. If you like my video, please subscribe my channel Physics Hunt 3. Thank you.